بسم الله الرحمن الرحيم والصلاة والسلام على أشرف الأنبياء والمرسلين. السلام عليكم ورحمة الله وبركاته. Okay, guys, we are from group 9. We have a presentation talks about memory management. So, about in the OS. So, what we'll talk about hierarchy memory, how to work, bagging, swapping, also swapping mechanism, fragmentation memory, the external and all of them examples, solutions, memory allocation, and we also talk about first fit, next fit, quick fit, and the best fit, also worst fit. Okay. So, my name is Abdulaziz Abdullah Bawadi, and those are my friends Hafizh, Almustofa, Assidiq, and Shidqi. Okay, we will start about the definition of memory management. So, memory management is a method in operating systems for managing operation between main memory and disk. So what does that mean? It means that the memory management is only a method, or you can say it a way that that is in operating system. So this is memory management. They do it for what? For managing operations between the main memory. It will be the RAM and the ROM, and disk. Disk here means the hard disk, HDD and SSD. So there is a condition. The condition says while a process is running. So the memory management is a method or a way in operating systems for managing operations between main memory and disk while a process is running. So what's the main goal of memory management? The main goal of memory management is, the first thing is to achieve efficient memory utilization. Second, memory functions, talks about optimize memory usage, ensure sufficient memory space is available, and prevent memory fragmentation. So next here we'll talk about the hierarchy memory. Hierarchy memory talks about the memories, or the type of the memories from the fastest to the lowest, or to the slowest. So first we have the registers and cache. The registers and cache, it's inside the CPU. So the CPU have two kind of memory, registers and cache. The registers is the fastest and the nearest memory to the CPU. So the CPU can use it for the process that can like looping, or you can say like repetition, or like that. So next we have the cache. Cache, it have three kind of memory, L1, L2, and L3. After that, we have the main memory. Main memory talks about the RAM, or we can say it's the RAM and the ROM, or the read only memory and read access memory, or read random memory. So after that, we have electronic disk. Electronic disk also talks about the main memory. It have the RAM and the ROM, or we can say that main memory have the RAM, and electronic disk talks about, or have two types, is it the RAM and the ROM. So after that, we have the magnetic disk. The magnetic disk means the hard disk, the HDD, SSD, both of them. After that, we have optical disk and magnetic tapes. So both of those, optical disk and magnetic tapes, are like very old, or most of the devices not using them. So most of the devices uses magnetic disk, electronic disk, main memory, cache, and registers. So how does it work? Here we have two type. We have the monoprogramming and multiprogramming. Monoprogramming means that one process in one time only. So imagine that we have here the RAM. The RAM. The RAM only will take one process or one program and will directly will execute it. So like that. In the same time, only one process or one program in the same time. But the multi-programming had or has here we have the memory, the RAM. It will like it will do or it will execute a lot of programs or a lot of tasks in the same time. So imagine that we have the program one is Word or Word, and the program two is Google and whatever. So the RAM it will works as multi-program. It will try to execute the first program, then the second program, then the third, fourth, like that. So it will execute all of them in the same time. It will execute all of the programs or all the process in the same time. But here in monoprogramming, no, it only will take one program or one task and then will execute it. And if there's another program want to execute, have to wait until the first program executed, like that. So
Okay. And the explanation, paging and swapping. Next is paging. What is paging? So paging is a scheme in the memory management. Is the allocation of several processes from logical memory to the secondary memory or RAM based on the page table. For the example, here the implementation of paging with the size of each paging being 4 bits, and so the total size secondary memory is 22 bits. So here we have to place this process to the secondary memory according the page table above. So process 0 is allocation from 2 frame 1. Process 1 is allocation to frame 4. Process 2 is allocation to frame 3. And process 3 is allocation to frame 7. Is the explanation of paging. Explanation about paging. Next is swapping. What is swapping? Swapping is the swapping the scheme to swap or temporarily move process with process from main memory to secondary memory when memory is almost full, and in and and if the second process has finished execute in the main memory, so process 1 will be moved back to main memory. Then so the example of the explain implementation of swapping on a computer is when we are opening the application and the main memory capacity is almost full, so this process will be temporarily moved to secondary memory. And this process will be moved back to main memory. Okay.
And this time I will to explain to you what fragmentation and how it works. And the first one, fragmentation memory. Memory fragmentation is a phenomenon that occurs when memory space in a computer system is divided into small pieces that are not used efficiently. There are two types of memory fragmentation: internal fragmentation and external fragmentation. Internal fragmentation occurs when the memory space allocated for a process or data is larger than it. In other words, even though the memory is allocated in large blocks, some of the blocks are unused, which cause waste of memory in the block. And next is external fragmentation. Occurs when there is enough memory space to store new data or process, but the space is fragmented into small parts scattered throughout the memory. This even though there is enough total memory space, there is no one block that is big enough to hold the required data. And the next is example how to work. So here I will give an example of how memory fragmentation works. First, internal fragmentation. For example, if an application requests 100 KB of memory, but the operating system only provides a 128 KB memory block, or for example, due to a fixed block size policy, then the remaining 28 KB in the block cannot be used by other application, because this activity does not use memory efficiently. And next is external fragmentation. External supposed we want to add a new program that requires 35 KB of memory, although the total free space 50 KB is larger than required 35 KB. The space is divided into small blocks, or such a 0 KB between P1 and P3, so there is no large enough space adjacent to accommodate the new program. And the last one is solution. External fragmentation can be overcome in several ways, including compaction, pegging, and segmentation, while internal fragmentation cannot be avoided if we use fixed size partition system, considering the size of the whole provided is always stayed. But there is one more way, namely the fragmentation, which is the process of handling files that experience internal fragmentation. A file set to be fragmented when it does not occupy contiguous space in physical storage. Okay, maybe that's just a little explanation from me. Sorry if there are any errors in delivery. Wassalamualaikum warahmatullahi wabarakatuh.
I will try to explain how memory allocation strategy works, and in this slide I will try to explain 3 of them of 6 memory allocation strategy. I will explain about first fit, next fits, and last quick fit. In the screen, as you can see, first I will try to explain first fit algorithm. First fit algorithm, an algorithm that searches for and use the first free memory block whose size is greater than or equal to the size required by the process. Okay, and let's go to the example. As you can see, guys, there's a table with five columns, and first column is there's 100 kilobytes, the second is 500 kilobyte, the third one is 200 kilobyte, fourth 300 kilobyte, and last column is 600 kilobyte. And the process that will be placed, that we want to place some process to the table, there's 212 kilobyte, 417 kilobyte, 112 kilobyte, and 426 kilobyte. First with works is they will process or checking one by one each table. Like if we want to put 212 kilobyte into the table, they will first check into the first one. If the process is bigger than the memory, they cannot be fit in the table because it's bigger than, yeah. So we check first the first column. It cannot be to place in because there is bigger than 100, and next we check again. There's 500 is bigger than 212 kilobyte, so the 212 kilobyte they will in to column number 2 is 500 kilobyte. And the next process is 417 kilobyte. As I said before, first fit management and memory allocation first fit, they will check first. It will check first and checking one by one. So we check again. 417 is bigger than 100 kilobyte, and next 500 is bigger than 417, but they will already used by first process, so we cannot input the second process to the second table, second columns. So we go on to the next columns is 200 kilobytes. Still 417 is bigger than 200, and next we check again to fourth column is 300 is still smaller than 417, and the last column is 600 kilobyte, and now it will bigger than 417 kilobyte. So the second process, it will into the last column, and next process is 112 kilobyte. Same as before, we check first. Still third process is bigger than 100, and we're checking again the second columns. The third process is smaller than 500 kilobyte, but again there is some process in their place, is first process, yeah. So we cannot put them to the second column because there is already have process. So we next to this third column, they will smaller than the third process, so it will come in to the third columns. And the last 426 kilobyte, again same as before, checking first, second, third, fourth and fifth. There will now come, there's no any space anymore, because second columns, third columns and fifth column, there is already have process each other, yeah. So the last process, it will enter the waiting list until one of process it will finish. I hope all of you understanding, you guys. And the next one is next fit algorithm. An algorithm that searches for a location to place the process by starting the search from the location where it last found a matching segment. So basically, next fit algorithm is same as first fit like before I explained, but there's something different how it works, yeah. So let's get into the example. There is some table again, same as before, guys, but in this slide I will try to explain with next fit algorithm, yeah. Same as before, first process, same number, yeah. So let's get it. The first is same as before, we're checking in the first column there is bigger, the process one is bigger than 100, and then we check the second column, there is smaller, so the process 2, it will come in to the second columns. Yeah, as I said before, the next fit is little same, basically is same as first fit, but there's something different. Like first fit, in the first fit we will checking by one each column, but in the next fit, if the process one has entered the column, entered the memory, like this one, yeah, there is process one is came into the second one, so the next process, they not must to start from checking the first column, but they will check by the next column after the process came in, yeah. So the second process, they will start checking in the third column. There is 200 kilobyte, yeah. So like this, we checking the the second process to the third columns, there is bigger than 200, and the next we're checking again, and they're still bigger than memory, and last they will fit because they smaller than 400, yeah? So they into the fifth columns. And then next, if they reach the end of the table and the last of the columns, in the next fit, and there is two options that will choose, that will take it, yeah, the with circular search or with or no circular search. By the default, next fit it will use the circular search, because circular search is we there's will be able to get a looping, so they can start again from the first column, yeah. By the default, next fit is use the circular search, but they can use no circular search. If there no use circular search of and the rest of the process, they will enter the waiting list because there's not be able to the back to the first column because there's no circular search. And in this time I will use the circular search by the default of next fit. Next fit. So we start again from the first. For the third process we checking again, there is no fit. The second, there is already have process. The next one is fit because they smaller than 200 kilobyte. So the third process is coming to the third columns, and the fourth process is not be able to fit in the all of table because they already have one of process each memory. So like before the 400 it will come to the waiting list. I hope all of you is understanding what I mean. Okay, let's next to the last section is quick fit. Alright guys, we enter the quick fit algorithm. Quick fit is an algorithm designed to speed up the allocation of memory processes into available blocks based on their size. So the aim of quick fit is to speed up the time in finding blocks that are suitable for a process. We want to all of you take notes. Quick fit is aim to quick or speed up the time. The quick fit will take the efficiency of time for the finding blocks that are suitable for a process. Blocks memory. For the example, like same as before, same table, same number of process, because it's easier to understand. In this quick fit, they just adjust depending on the system they want. If they're for this example, the system they want to focus for speed or efficient. If we choose the speed, so like this, the process one, there's no checking at all. The process will see their speed there for enough space for the for the process one, what blocks their fit, the speed. As we can see, the first process they will in to the second block or columns because they're smaller, and the second one, the 470 kilobyte, they will come to the last because there's no checking in the quick fit, because like as name, quick fit, like before, is algorithm designed to speed up the allocation of memory process into available blocks based on their size. So the aim of quick fit is to speed up up the time in finding blocks that are suitable in the process. There's no need to checking one by one like first fit or next fit. They just go on, like this. Second process they will entering the last blocks or column, and the third process they will entering the third column, and fourth process they will enter in the waiting list. But if we want to use quick fit for the efficiency, so the process one, it will entering the fourth columns or block, because there's a gap between 300 and, but there is a little gap between 300 and 212, yeah. So the first process, it will come to the fourth, and the second process, it will entering the second columns, because there is little differential, little gap between 500 and 417 like before. And process 3, they will entering the third column, same as before, because there little gap, and the last column and the last process, they will entering the last column, because there's no option to the entering any column, but there is some empty room, that enough space for the last process. So if we use for the efficiency, there's no any of process that will come to the waiting list, yeah. So just like that explanation from me. I hope you guys understand what I'm explaining 3 of algorithm fit. That's all from me. Thank you.
Okay, the next is Hafizh algorithm. Select the smallest block class and not to satisfy the request. So the best Hafizh algorithm is to process the smallest blocks which are sufficient, and allow for the entry of the process which in the best width will immediately check which block is the smallest and fish for the entry of process. Just a give sample, we have any process one, we have any process 1 is 212 kilobyte, process 2 is 417 kilobytes, process 3 112 kilobyte, and process 4 is 426 kilobyte. Okay, so from the system, process wants to request entry into its block, so we check which block is the smallest and first to enter. It turns out that that fish is in block 4. Then process 1 will enter in block 4. And the next, why doesn't process 1 enter blocks 2? Because the best fit algorithm places the small blocks which fits and is sufficient for a process to enter. So process 1 enter in block 4. Okay, so the next step is the same. Process 2 will check which small blocks are sufficient and fit. It turns out they are in a block 2. Then process 2 will enter in a block 2. Okay, and for process 3 and 4, then method is the same. He will check which small blocks fit for the process 3 and 4 to enter. It turns out that process 3 enter block 3 and process 4 will enter in block 5. That is guys for the best fit algorithm. The next is worst fit algorithm. Worst fit algorithm is selects the last block that is large enough to meet the request. So the worst fit algorithm is opposite of best fit, where best fit places process in the smallest box and worst fit place process in the last box. Just give example. We have any process 1 in 212 kilobyte, process 2 in 417 kilobyte, process 3 in 112 kilobyte, and process 4 is 426 kilobyte. Okay, we'll check a process for process 1, which is we check which the block is the large for the process to enter. And we'll check for process 1. We check which block is the large for this process to enter. It turns out the block that fits in block 2. So process 1 will enter in a block 2. And for the next process, the same as for process 2, 3, and 4. We check which of the last block fits and sufficient to enter to the process. It turns out the process 2 can enter in block 5 and process 3 can enter in block 4 and process 4 cannot enter any block because there is no one to accommodate the process. So process 4 will be in waiting status. So the next is system body. System body is a way to manage computer memory by dividing it into manageable size using size that are powers of 2. So the system body is to place process in not at fit where the algorithm is by dividing the blocks until they are in the right shape and fit for the process to enter. For example, like we have a bird, then there are 3 our friends who want to ask for the bird. Of course we share it equally. No one is too big or too small to get a share of the bird. Well, that is the system body. Okay, for an example for the computer, we have process 1 is 64 kilobyte, process 2 is 100 kilobyte, process 3 have 200 kilobyte, and we have block is 1024. So we just check from process 1. We check whether process 1 can fit in the 124 kilobyte block. Actually not, because apparently not, because it's not still too big. The fat is 120 kilobyte into 512 and 512 kilobyte. We can check again whether it can fit or not. Apparently not, because it's still too big. So with the fat another 512 kilobyte becomes 256 and 256 kilobyte. Then we check again whether process 1 can enter or not. Apparently not, because it's still too big. Then this 256 block, the block is divided again into 128 and 128 kilobyte. Then we check whether process 1 can enter it in the block. Apparently not, is still too big. Then the block 1 to 8 kilobyte, the fat into 64 and 64 kilobyte. Then we check whether process 1 is can enter. Yes, process 1 can enter in block 64, and a process 2 and 3 are the same methods. We will check until he can enter the block that is correct for him, and process 2 can enter in block 128 kilobyte, and process 3 can enter in the block 256 kilobyte. 200 100. Okay.
So guys, here we are again. We have the last slide talks about the conclusion. So we will like summary all the definition that we'll talk about. So first we have the memory management. Say it is a method or is a way in operating system for managing operations between main memory and disk while a process is running. So the main goal of the memory management is to achieve efficient memory utilization, and the way management works in many programming is that it only allows one user or one program to run at a time or at the same time. All resources are fully controlled by the ongoing process, whereas in multi-programming, a program will copy a partition. If the program is larger than partition, it can't be loaded program, can't be executed. If the program size is much smaller, the remaining space may not be available, used by other process, and that's called internal fragmentation. And in management, there are pegging, swapping, fragmentation, and memory allocation strategies, which are useful in managing memory in the operating system. So last thing we have swapping, the definition of swapping. Swapping is a process of swapping a process temporarily into a secondary memory from the main memory, which is fast compared to secondary memory. So thank you for being attention with us, and we hope all of you have learned a new thing and have understand what we have said about the memory management. Assalamu alaikum wa rahmatullahi wa barakatuh.